welcome to my YouTube channel. So today I'll be doing linear regression model using this data set that is provided below. Alright, so without further ado, let's start. Yeah, okay, so as you can see, I went to this website which I have provided the link below, is description below, right? So if you want the link, you can just click on it. So you can see this is the data set for the entire world, and you can just click on this download button here, CSV or Excel sheet, okay, which I've already downloaded it. Okay, so this is how it looks like. Alright, basically what you can see, there's a lot of the data size, the data source is last updated from 28th of January 2025. And we have lots of countries with the year 1960 being blank everywhere. Okay, so starting from 1961 and all the way to 2023. Okay, I don't want to take all the data sets for every country, so since 1960 doesn't have anything, right, so I'm just going to copy all the way 1960 all the way to 2023 and paste it in another worksheet. And because I'm Singaporean and I live in Singapore, so I'm just going to find my country, Singapore, SINGAPORE. Where is it? Where are you? I can actually Control F and find it, but I want to see all other countries also. Wow, there's a lot of countries, yeah? Wow, okay. So never mind, I just stick for Singapore over here, which is 213, yeah? Okay, you can just right click and copy this whole data, and then just open up a new Excel sheet and just paste it here, which I already done it also. Okay, but if you notice 1960 it has nothing, no data, so I'm just going to delete this. Okay, so let me just delete. Alright, so it starts from 1961 basically. Alright, and I give you time to do it, and maybe you can follow along with me later on, right? So take your time. Okay, without further ado now, okay, I'll close all this. I'm going to use Google Colab. You can use Jupyter Notebook or your Visual Studio, it's all up to you. But in this video, I'm just going to use Google Colab because it's much faster, I feel. Okay, so once I have opened up my Google Colab, I just go to this folder and I'm going to upload the file which I've renamed it as Singapore.csv. Okay, so here it is. So I just open it, and so while loading, I can actually type the code over here. So every time you want to start something, right, for visualizing, for importing for loading data, you always need to import certain packages. So in this case, I'll import endless SPD. This is the most important thing that every data science projects always must have this. Okay, alright, and then what else I need? Maybe I need NumPy. If you just as you can see that this data set does not have much arrays, but perhaps if I got time, maybe I want to predict more what do you call it, more visualization for what will be the GDP for 2025, 2026, etc. Okay, yeah, because as you can see, the data set, alright, is just showing us up till 2023, just no 2024, even though now it's already February 2025. And even if I were to go to the website, right, and this is under Singapore, we see under GDP, let me see, GDP per capita, yeah, even they write 2024 here, but they didn't finish off. Okay, it ends at 2023. So 2023, the GDP per capita is 84734.3. Currency is in US. Okay, if I to check here, so I cannot change to SGD. Okay, so this is a good way that you can actually try to visualize what will be the GDP per capita in 2024. Alright, So that's what we're going to do today. Alright. Okay, without further ado, let's begin. So what else I have to import? Definitely have to import matplotlib to visualize graphics, right? To plot something, to plot a graph, or you know, whatever that can be visualized. So matplotlib, okay, it automatically that will be it. And also I want to use Seaborn SNS. So yep, this is the thing that Google Colab is nice. You know, I just start a little bit and they finish and complete it out for me. Okay, I also want to import warnings because I got a bit frustrated whenever I do something. There's always warnings, which is sometimes unnecessary. Okay, the warnings is really unnecessary. So I'm going to tell the warnings to be ignored. Okay, yep, that's it. Ignore any warnings, they will not show up. And then because you're doing some prediction, that's the reason why I need sklearn. Okay, sklearn dot linear underscore model, because we're going to do linear regression model, right? So import linear regression. Okay, yep, that's it. So let's try to run this. Perfect. Yes, a tick means it's perfect. Alright, no mistakes. Allow. Let's now try to load the data. It's a good practice to actually like write the comments. So just like load the data. It looks neater. So like that, right? So I'm going to create a variable called df. Maybe it's the shortest one. And then okay. Now my data set is not data KC. So my data set is called Singapore here. Okay, so I'm just renaming it as Singapore, right? So I'm going to run. If you run, you can't see anything, but if you want to see what is in this data set, you can maybe perhaps do df.head, you know, and it will show you the first 5 rows. Okay, but as you know, this data set, it only has one column, one rows, right? So yeah, it doesn't show much, right? But it does shows all the columns of 2020 till 2023. So it has 68 columns. And the unnamed 0103 is something that I don't want, because over here when I paste it, right, over just now when I paste this 1961 here, all okay, when I paste GDP, whatever, there is something over here from I just copy, right, and the whole thing just being copied. So this part here becomes blank. So I'm going to remove this. Okay, so how am I supposed to remove it? Okay, before, if I want to copy one by one, it can be copied as well, but I'll show you a shortcut. Let's see, I just like print df.columns. Okay, it will show me all the columns. So here is a way that I can just copy it, because I don't want all these things. So I just Ctrl C. Okay, now I'm going to drop this. So how to drop that? Okay, let me comment first. Drop the unnecessary columns. Okay, because it's really unnecessary. So unnecessary columns, I spell it correctly. Yep. Okay. So how you? Oops. Great. It even prompt for me, and I just need to click tab. Okay, but I don't need all this. Instead, I need no, that's not the way. Okay, I have to define these other df drop columns, because I want to drop the columns, right? So equals, these are the columns that I want. Oops, not this bracket. These are the columns I want to be dropped. So it's not I Ctrl C, now I Ctrl V. Yep. Yep, and close this. So I don't need all these X's or whatever. Alright, delete. And let me see, df.columns. Okay, df. Oh, I have to of course close it. Yeah. And I want to make it as df also, so that I will not. I can call back this variable again. Okay. So let me try to, let me see, df drop columns equals, there's a mistake now, this one doesn't have open. Yeah, no, it's fine. Okay, so let's try to run this. Yep, now it doesn't show it to you, right? So Maybe you can type in again the f.head so that you can see what's the difference. Oops. Okay, never mind. Sometimes you can just run all and see. Yep. Okay, it works. Okay, so all these unnecessary columns has been dropped. No more. Great. So far so good. Am I going too fast? Anyway, I hope you can stop the video if I'm going too fast or whatever. You think that you need to repeat it, you can just, you know, rewind it, whatever. Okay. And I also noticed, right, this kind of graph is a bit funny because 1960 is like the header, and what is this? Suddenly start with 0. So it's like, by right, you know, it would be nice if you have these are the years and these are the GDP, right? And it would be nicer also if we'll have two rows instead of these three, you know, columns. So why not I transpose it? Okay, so I'm just going to transpose it. I'm going to transpose the data frame to make years, the column name, and GDP values, the row values. Okay. So what I'm going to do now is just dt equals, sorry, df equals to df dot transpose is correct, but it's a shortcut actually, no dot t instead of just typing the transpose. Okay, so when you want to see the results, right, you can just df head again, right, and let's try and see. Yeah, perfect. And now it becomes like you having these two rows and all the 64 columns is no more 64 columns like that, right? So you have two rows. Now you have two rows, right? Isn't it nicer and neater, right? Rather than this, right? Okay. I also noticed something, right? What I noticed is that well, this 1960 is domineering, is in bold. If it's in bold, it means that it is the header. So why is there 0 here, right? So isn't it nice to have a header here as year and this header as GDP per capita? You know, okay, and this one shouldn't be the, what do you call it, the header. The header should be the top here, on top here, right? So let's make this 1960 all the way to 2023 to be not header, okay, not to be the header. So how am I supposed to do that? Well, let me just what do you call it, maybe let me just comment it first, right? So actually have transpose the data, but before that maybe I can also see the tail, f.tail. Yep, yeah, till 2023. Okay, good. So what I can do is, let me try to reset the index, okay, to make it to years, okay, and to make the years to be a regular column, okay, just like the GDP here, right? So yeah, okay. So how to reset this? You just go to dr equals to dr dot reset. Yeah, and then you tap on the index. Great. So when you run again the df head, you'll see it will be in a normal, just like this GDP per capita. Okay, the value is similar. It's no longer a header, right? So now it's fine. It's all in like rows like that. Okay. Alright, but still a problem because the year is indexed and this GDP per capita is known as 0. So it's not really practical, right? So I'm going to change this index to year and this 0 to GDP per capita. So in other words, I'm going to rename the column, right? So let's rename the column. Rename the column year. Okay, I'm going to rename it as year and GDP capita. Okay. Alright, so how to do that? You just have to df.columns. Okay, so these are the columns that we want to change. First, the index columns. So yeah, oh god, it's super nice. Everything they help me out, just pop up. Okay, great. So when I run it, right now you'll see, yep, here GDP per capita. Perfect. Right, simple as that. So now I think almost the visualization, but before that we still need another thing. Whether have we cleansed this properly? Now it looks great. Now it looks more clean like that, right? But is this 1960 and this per capita a string or an object, or it's a float, which is a decimal, which is good if it's a float for GDP per capita? So let's check it out. Okay, so there's no code here. Alright, so let's just df.info. Okay, so I no need to comment now because info is really know this information, right? So shift enter, let's see. Okay, GDP per capita is good, it's float, meaning there is a decimal number. So the data entry person is good. Okay, yes, she has changed this to decimal or a float, right? But the year, she doesn't change it to any numbers. It's just a string, it's an object. So we have to convert these into numeric, because if not, later on when we do prediction, we'll be in great problems when we have to do this so-called like splitting the data or do classification, okay, etc. So let's change this. So what to do is convert year. Convert the year column to numeric. Okay. So how to do that? Okay, wait, I need to have some space here. Looks neater. Okay, so we just go to the here. Okay, so this is a capital letter, right? That's a capital letter. So stick to what is, you will not be able to identify. Okay. It does that one for me also. So just tap and that's it. Okay. So now when you go to df info again, let's see whether it changes. Definitely, yeah. Now it is an integer. It has been changed from object to become numerical. Okay, great. So now, since it's already an integer, we can do visualization. Okay, so what kind of visualization I can do? So let's visualize the data. Visualize data distribution, perhaps. Okay, distribution, because it hasn't much, also just 2 rows, right? It suggests for me to do histogram plot, but I think because I want to do linear regression, so I'm going to use regression plots. Okay, and yeah, I thought for me, great. Okay, so SMS. Okay, good. Even has titles and that. Okay, that's nice. So play here, data distribution is a title. The X label is year. Yeah, the Y label is GDP per capita. And yep, it's showing us this data. 1960 is nothing, basically 0, right? And all the way to 2023. If you see 2023, did I did the tail just now? The F tail, the F8. Let me see if I did the tail. 23 is about 8473, so it should be somewhere around there, right? So it's above it. Yeah, that's good. Alright, so now it's time to do more visualization, okay? Because they say this 1960 all the way to 2020. But the 2023 not really can be seen. You can see, but like, you don't know which one. It's really 21, 22 here. You don't know, right? So maybe we filter it a bit so that I can also see the year from maybe 2018 onwards, you know. So let's try. Let's do the code. Let's try to filter the data. So filter data for years 2018 onwards. Okay. So I just call it as filtered data. Did I spell it correct? Yeah. Okay. It's so nice to just do for me. Okay. So I'm going to make it more than or equals to 2018. Yeah. So if I want to do this, yeah, it's going to show it to me. The data is filtered from 2018 all the way to 2022. The rest, like 1960 all the way before 2018, will not be shown. Okay, so I'm going to visualize this. I'm going to create a graph also. Okay, for this 2018 or 2022. So the same method like what I did for this, right? Okay, you can just merely copy. But it's okay, like this one, what do you call it, this Google Colab, even though you type little bit, they help you to type a lot already, right? So no need to copy also, like most of the thing will type for you. So here I'm going to visualize more than or equals to 2018. Yeah, equals, sorry about that. Okay, so how to visualize it again? I use the SNS. So yeah, you see, I haven't done anything and type for me. So instead of using the FD data, use the filtered data. Okay. Yeah, isn't it cool? Yeah, but maybe, yeah. Okay. I think it's cool. Yeah. So I just run it. Yeah. So you can see now it's from 2018 to 2023. Yeah. So perfect. Yeah. You can see it more clearly, right? It's from 1960 to 2020, somewhere there. And this is the graph from 2018 to 2020, because it's going to be so huge, I think. Okay, so difficult to see. So yeah, perfect. Okay, so without further ado, now that's the main important thing that I do this video is for data science, right? To predict, right? To do prediction. So let's start doing the prediction. So before we do prediction, right? Just like if you want to visualize data, of course we have to have what do you call it? You have to load the data, you know, clean the data, right? Like prepare the data first, and then you can visualize it, right? So for prediction also we need to do certain things, right? So first I have to create instance. Okay, so what is the instance I'm going to use here is linear regression, so I'm going to call it LRI maybe. Is for linear, this type of linear regression, and this is for I for instance. Okay, this way you can name it anything you want. This is a variable, you can call it as model or anything you like. Okay, so I just call it LRI, and then I'm going to train the model. So you create the instance, I'm going to train model. Okay, and I'm going to use LRI fit. They already done it for me. This is super cool. Yeah, nice. Okay, so I train this. Okay, so it goes out, the linear regression come out here to fit in. Okay, and then I'm going to make the prediction now. Okay, so let's make the prediction. Oh my god, why did you open it? Type wrongly, is it? No, it's a hugging face. Okay, never mind. Make the prediction. Make the prediction, and then let me call wait, before I make prediction, I think I should create data frame of prediction. Yeah, so let's create the data frame first. Create a data frame prediction. Okay, and I'm gonna call it prediction underscore df, and pd dot data frame. And this one I'm going to call it as the year, right, that I want to predict. So well, it gives me a lot of years. I just want to predict 2024, right? So I'm going to remove all this and just type 2024. Okay, so let's see. Yep. Okay, I didn't close that, so let me close this. Yep. Maybe it's so much data. Never mind. Okay, so once I did this, I tell the what do you call it, the model that I want to predict this year 2024. So I create this data frame, and then I'm going to ask it to make the prediction. Okay, so make the prediction, right? And prediction equals LRI. Let's see how use the model LRI. Okay, good. You just use this model. Prediction DF. Right? Yep. And I'm not going to use for the year. I'm just going to predict the GDP, right? So the entire thing prediction DF. Yeah. Okay, for the year 2024. And then I'm going to ask it to print for me. So print prediction. Right, so there you go. Let's see what happens. Oh, I haven't run this. Okay, so yeah, now it prints for me. So they are making a prediction that by in the year 24, this will go, the GDP will go up to 9,000 something, which is kind of wow, a lot, yeah. Yeah, a lot, yeah. But it's because I took this filtration. I've done this filtration from the year more than 2018, right? If I didn't use this, alright, it will predict from me from 1960, which actually I don't want because that's too long of the years, right? Yeah, you got what I mean? Yeah, so let's say if I want to maybe predict, okay, maybe I don't want to predict from visualization from, okay, this one, what do you call it, maybe I want to predict not from starting from 2018. Let's try to predict, let's say from the year 2020. Okay, let's see how is it. So here I have told it to do the visualization data, so I create a filter from more than equals to 2018, right, to manage to create this graph. But let's say I want to do a prediction of starting from the model starting from 2020. So how does it work? Yes, I got to again filter the data from, let's say, 2020 onwards. Okay, so again you do filtered data. Yeah, it's perfectly fine. Alright, and yeah, this is how it works. It shows you the filtered data, right? But I don't want to show it to me ahead, so I just remove this because it takes a lot of space. Okay, what I want you to do is just to do the prediction. So again, I have to create instance. So this is just a repetition, but for this just now is more than 2018, more or equals 2018, because I want you to you to see that by training the model from where the year begins also makes a huge difference. Okay, let's see, if I were to put this 1960 lah, okay, 1960, 1960, sorry. Okay, so create instance. Okay, wait a minute please, sorry. The instance, so again it's the same thing. LRI again equals to linear regression, right? So run again, and then once you create the instance, you train the model again, right? Train model. So yeah, so when you train the model, it's again LRI.fit. Yeah, again you do it for me. Yep. So and over here I can again create a data frame, prediction, and prediction Okay, so this is good enough for the year 2024. It's the same year that I want to predict here. But you see the results will be different, and I'll tell you why. Okay, so just make the prediction. Oops, God, I always have this problem typing the wrong place. Okay, make the prediction. Make a prediction. So again, prediction, yeah, the same thing. Okay, so when you print, you see different results. This is 98215, right? And this is 91895. You see the difference? But if you were to run from here, okay, yeah, it shows very huge difference. Why 63201? Big huge difference, right? And where is it? 918989. Okay, why? Because if you were to see the graph itself, alright, the actual graph in 1960 is like 0. Then it slowly is very slowly let the GDP per capita increase very slowly. It increase a little bit, then again goes like straight again and goes up a little bit, just very slow, go up. And even in this like 20, I do not know which year, you can see the data, it goes down and then goes up and goes down and goes up. So for that reason, when you're taking the data set to be trained from 1960 onwards, right, more than or equal to 1960 onwards, it is taking all the data, let's say from 1961, because 1960 got no data, so 1961 and all the way to the 2023, and it's going to follow on the trend, right? That's why it's not so huge, right? But in this case, when I change it from, I want it to start from train the data to make a prediction starting from 2018, right? Where is it? Yeah, 2018. Where is it? Yep. Yeah, here 1960. Wait, there we go. Yeah, more than or equals 2018. It's going to train the model starting from 2018. So from 2018 onwards, you can see it goes down a little bit in 2019 or this year, not too sure what, but at least not super high, not super high going down, right? So that's the reason why it's this value is higher than the predictions that we create in 1960. Okay, so yeah, I hope you understand. Okay, so let's do prediction. I think really 1960 not practical because it's also like very long, right? And as you can see, our rate since then has always been increasing, right? Hardly drops. Where if drop also maybe minimum, not so much. So maybe I change this again to maybe what would be a good number, yeah, to start off. 2010 maybe 2020 even. Okay, maybe 2020 onwards lah. Okay, so 20. Okay, so already this 2020 and I run it again. Let's see what happens. Okay, yep, this is more logical, I guess, because even if you were to go to Singapore GDP growth, right, in 2024, mentioned that Singapore GDP grew by 12.3% in the fourth quarter of 2024 and by 4% in 2024. So in 2023 is where is it? Yeah, in 2023 it was how many, like somewhere also around 8,000 something, right? Let me see the data again. 2023. It didn't show here. This is the head. Okay, let me see the tail. Where is the tail? The tail. Yeah, the tail. 2023 is 8473. So to go up to 89387 is more realistic if it's about 4%, right? increment. Alright, so that's the cool part, right? And anyway, because just now I import numpy also, so let's do the prediction that make use of this numpy, which is arrays, right? So let's create a data frame. Data frame for multiple years. Okay. So prediction we have. Yeah, so you see, it even gave me a lot of year until 2030, but I don't want so much. Okay, maybe just predict until 26 because you do not know what's the upcoming years, or maybe there's war in America, or then it will drop down, or maybe China will goes up, you know, or maybe there's I don't know. we cannot predict also. So this is just prediction by the patterns that goes from the machine learning, right? So yeah, just now it's 2025, so I'm just going to predict before 2024 because they didn't predict it in this data set, and 2026 also. So the same thing again. I'm just repeating this again, right? So by this time I think you should be very familiar already, right? Make the predictions. So predict, yeah, it's like totally comes off. Right, so again, right, so predictions. Oh, I say make the predictions. Oh, why is it only one? Make the predictions. This is not correct. Print the predictions. Seriously? Oh, maybe they confused with this, yeah? So this is predictions we have. Yeah, so we should not make this as okay. Okay, prediction.df is going to be data frame year. This is correct, and then you make the predictions with array, prediction, print prediction. Why is it just putting for me one? Does it confuse? I wanted to create a multiple prediction. What is the problem here? Create a data frame for multiple years. Prediction would be a period.data year. What is the mistake here? 24. Oh, I forgot this. So that's the reason, right? So be careful also. If you do this, they might think this is just, you know, you're not asking it to predict these years. Okay, so let's try to run this and try to run this. Hey, still the same. What is the mistake? Help me, help me. Great. Did I make it correctly? Maybe I should run all over everything again. Maybe because yeah, runtime also doesn't work. This is really sometimes you program so much until you don't know already what is the mistake. Prediction for the f is pd.data frame year. Yeah, this is correct. Open bracket is 2024. 2025. Sorry about that. Give me some time to check what's the problem. So let me make the prediction. Where is the predictions? Yeah. Prediction, yeah, is equal to L, right? Predict the prediction we have, which is this, and you print the prediction here. Yeah, oh god, just because of this little s. Okay, so you can see this is year 2024. Alright, and then 2025, and then 2026. Okay, finally, cool. Alright, so okay, maybe one last thing, okay, before we wrap everything this up. So let's do visualization also for this. So maybe before I create visualization for the prediction, maybe I want it to be together with whatever historical data. with this prediction. So let's plot historical data, which is from the Word Excel sheet itself just now, right? Yep, but I don't want scatter plot lah, okay? Maybe messy a bit. So maybe PLT plots. Plot. Should I use DF, the year? Yeah, this is what I want. Okay. But if I were to use this, it's just going to show me a straight line. Even though I haven't even put future predictions, but it even tells me, okay, if you plot the historical data, you also should plot the future predictions. Very nice. If I plot this, right, you'll just show this line. Yeah, which is nice, but I think if I were to create the future predictions later on, then it will run over it and then you can't really see properly. So maybe I should, instead of this, maybe I should make a marker. Yeah, so maybe a marker, maybe I make the marker as O and then comma. Yeah, and the line style also, I want to change the color later, make the line style also different from future prediction. So maybe the line style will be just like dash like that. Okay, and color maybe blue. Color equals to blue. Yep. Okay, so I think it should be okay now, right? Let's see, let me try to run. Yeah, I see there's they make it into like this mark, right, which is the O part. Okay, so it's in blue. So the part for the predictions, it should be maybe in other colors, right? And it already done for me. Great, I just tab it. It even asked me to do the label and the title. Great, I just make use of it. Yep. Oh god, why is it like that? I know, because in these predictions, right, we have not actually do the conversion do the conversion for, I think, the date, the year. That's why the year is forward. Something wrong. Okay, so remember before this, right, we have actually convert the data, right? Where is it? Try to run some of that. It does change. Okay, or we have to run it again for the prediction. Yeah, for prediction still we have to convert the year. So remember, before we did all this and we cleanse our data, right, for visualization, we actually have done this. Where is it? Let me see. Yeah, convert the year column to numeric, right? So over here also actually we have to do the same, but this is for the prediction. Alright, so okay, if not, it's going to look so ugly like that, right? Because it doesn't recognize actually the date. So before all this, so let's go up a little bit here. Okay, at least I can do this. So maybe I have to create the prediction for the, what do you call it, the year. Okay, so yep, so let's try to do it. Okay, so let me just give it, convert the year, whoops, year to numerical, right? Just like this, the same, right? Which I quite don't understand why actually I have to repeat it. But never mind. Yep. Maybe because this here is in integer, right? So it should be integer, right? But why is it? Okay, never mind. Let's do it again. So convert the year to integer. Okay, to integer. So let's see, df year, oops, equals the df. It does for me. Okay, never mind. It's gone again. Year, oops, yeah, S type. Tab. Yep. Okay, so this one is going to be the predicted prediction of the data frame, right? So prediction of the data here. Okay, so I'm going to put here. Yep, and this is going to be the equals prediction. Yep, as it is like that. Oops, yeah. So yeah, that one is just now not for the prediction, but here is going to be for the prediction. So let's try to run it now. Yeah, now it's fine, perfectly fine. Okay, so as you can see, from 1960 all the way it goes up, and for 2023, 24 and 26 it's also going up and raising, and this is basically the value. Alright, so I hope you have enjoyed and learned something in this video, and if you like it, please subscribe to my channel, and also comment. Maybe you want me to do more videos, or maybe you feel this video is too slow or too fast. Any comments? Alright, so thank you so much and have a good day, and may your intellectual journey towards learning something new be a very, very happy one. Alright, take care, have a nice day. Bye.